start a new project, you need to have a clear mind and an empty trash can. I made my mom this candle. The wax was hot and I didn't know what to do, so I made these legs and they look really crappy. This one wiggles. Normally I would just send it out the door, but it's for mom. It's gotta look intentional. Let's take this off. My old coworker Jeff told me that isopropyl will go in between the hot melt and the shell-based substrata. I use a work mat to help me know where to put stuff. Now we need to hit it with a pokey stabby. Any sort of tool used in the act of poking and stabbing. This pokey stabby's too big. I need a micro-class pokey stabby. The success of the whole mission hinges on this moment. Complete removal. Thank you, Jeff. Now we gotta draw. Man, it's really hard to work when you have to switch between the fine arts and the coarse arts. Now we're gonna discuss leg design. It's gonna be some kind of two legs that stick out with a flat surface that sticks here. I just want to discuss the nature of the section of the leg part component that will be touching the shell, okay? That's what we're gonna discuss. Let's make the wrong design first. Basic design. Yeah, boy. C shape. Adhere to this shell like this. I just wanted to talk a little bit defining why it's no good. Let's take a look at a top view. Okay, I gotta draw this whole shell. Damn, this is hard. Bottom view. The leg's gonna go somewhere in this region. Let's take a cross section of the shell in the region where the leg is in contact with the shell. For fun, I've colored in this cross section. You're seeing the inside of the shell, and you're seeing the inside of the wax, and you're seeing the inside of this joint here that is what I'm talking about right now. This blob here is the epoxy that's going to hold the leg in place, and this small circle is the center of the leg inside the epoxy. Let's look at this area in more detail. Here's a detailed view of the leg attachment location. In the background here, you would have the wire leg. How does the leg connect to the shell? You've got the copper leg attached to the epoxy joint, which is attached to the shell base. What worries me is the connection of the copper leg to the epoxy joint. And here's why I'm concerned. When this is in use, force is going to push on the leg this way and want to twist our leg attachment. As this twists, the shape of copper here, when you look at it in this way, stays the same. The circle is symmetric as you turn it. That means that the only thing keeping the leg in place is a chemical attachment along the boundary. You can't always trust a chemical attachment like this, because like what if the copper would have had some corrosion on it that flakes off easily or something. Okay, let me show you with the actual shell so that you can get a better picture. I want to stick this leg shape on the side of the shell using epoxy, and you can kind of already see that if it's just a straight leg, there isn't much holding the leg in place. What we gotta do is make the copper shape have some sort of asymmetrical cross section. I drew this line wrong, but whatever. Just go for it. Just put some sort of deviation in the center bit, and here's why. Look at the cross section now. Operational force. It's pivoting here, then this section is going to twist up. Try to imagine this just moving up, just like a fraction, just a tiny, like, infinitesimal amount, and deforming the epoxy, and the stiffness of the epoxy is going to resist that motion. Whereas in this situation, there's no deformation of the epoxy. It is purely an adhesive interaction. Here we can rely on the cohesive nature of the epoxy to stick together and trap the copper in this oddly shaped cavity. So we're done. Let's build it. With the epoxy, you gotta wait for it to cure. You cannot count on being able to hold the two things together still enough and long enough to make it work. Trust me. So ironically, the thing that started all the problems is going to be our solution. We're gonna use the hot melt glue to fixture it while the thing is curing. First, we need to make better legs. This is stupid. This sets in 5 minutes. Item can be handled in 10 minutes and full bond strength in 1 hour. I snip your tip. Boom, boom. Do those look equal? I hope. Mix thoroughly. All capitals. Now we wait 5 minutes. I'm gonna go to McDonald's. Alright, we're back. Here she is. Here's the epoxy. Comes right off. Here we go. This is the finished project. There are my new legs. Very cool. The only step left is to ship it to California.